Hello everyone, welcome to this problem called longest subarray with maximum bitwise and. So basically this problem is marked as medium, but if you stay to the end of the video you're going to see that this is actually an easy problem. You just need to be able to frame it correctly. Let's say we have an array of nums of size n. Okay, consider a non-empty subarray of nums that has the maximum possible bitwise and. So this is the tricky part of it. What is bitwise and? So bitwise and is actually like the bitwise operation using the and. So in other words, let car be the maximum value of the bitwise and of any subarray of nums. Then only subarray with the bitwise and equal to k should be considered. K to be the maximum value of bitwise. So if you want to maximize the bitwise operation between values, you definitely need to pay attention to one thing, and we are lucky that that thing has been mentioned here in the hints that you can use. Notice that the bitwise and of two different numbers will always be strictly less than the maximum of those two numbers. Let's say you have two numbers. If the numbers are actually different, that means in their binary representation there is always going to be a bit where they are actually different. And when you are going to use the bitwise and on those elements, what will happen is that where they are actually the difference, the result is going to take the 0, so it's definitely going to be less than the initial biggest one. So given that you know that if you apply the bitwise representation of two different numbers, it will be always straight than the maximum of those two numbers. For you to maximize k, you need to make sure that you are applying the bitwise on the maximum element of the array. So what does that mean? That means if I find myself with a subarray consisting of only the maximum element of the array, the bitwise is going to be the same value, which is actually the maximum. Since it's the maximum, there is nothing above the maximum, right? So what does that mean? That means for this one, for instance, I'm going to find what is the maximum of this array. The maximum is actually 3. So now the task will be to find the subarray with the biggest size of 3, which is actually here, this 3 and 3, which is actually the size is 2. Make sense? So if I'm here, what is the biggest element in my array is 4, and what is the maximum subarray containing only 4? This is actually 4, so just return this. So like I said, this problem can be reframed as finding the length of the maximum subarray containing only the maximum element of the array. As simple as that. So now that being said, how do we compute the length of the subarray containing only the maximum element? So I'm just going to use a straightforward approach. I'm going to look for my element from the beginning to the end, and whenever I'm seeing an element, if it's actually the biggest element I'm seeing is my maximum, and I'm looping, finding the continuous subarray that I can have until I have an element breaking the loop. And once I have an element breaking the loop, if it's actually bigger, I will reinitialize everything and I will start back. If it's not bigger, I'll just keep my previous solution and continue loop until I find someone bigger or equal to the previous maximum. Keep in mind that the or equal is really important, because an array that you are seeing now can be one valid subarray, but there may be another array in front which is actually the biggest subarray having the maximum. So let us start coding. So we are going to have, I will have in my maximum, which I will start initialize at 0. I will have a counter. This is the guide that will help me to count the continuous subarray. I will initialize it at 0, and then I will have like my solution, which is the final solution I will return. So you guess I will turn solution here. So that is why I'm having a solution. So now I'm going to loop here of nums, and for each of the element, what will happen? I'll just say if the nums is actually equal to the maximum. So this is the specific case. I'm going to increment my counter. When the maximum is equal to the num, I'm incrementing my counter. Else, I'm falling now into my reinitialization. So yeah, in this else, the first thing we are doing is that we want to evaluate the solution. So we want to make sure we compute the solution of the continue element of the maximum that we just made, which is solution equal to max of solution and the counter. Now when you find yourself in the else, that means you have something which is breaking the loop, and if which is breaking the continuous, I would say so. And if you have something breaking that continuity, what you need to do is that you need to initialize your counter. Perfect. And now you need to check here if now the num is actually greater than the maximum. What you would do here is that you're gonna say the maximum is actually taking nums, and you're gonna say the solution is actually taking 1. And what you will do, you also need to set your counter to 1 here. Let me explain this. Let's say I have this. I have a 2 here, which is my maximum. Let's say I don't have this. I have 1 here. This is going to break. This is going to break my my continuity. But when I will be here, what will happen is that the one before him was different from the maximum, which was 2. So the solution kept a value which is actually the continue here, which is 1, and the counter went to 0 because we find an element which is actually breaking that continuity. So at this point we have a maximum which is 2. So when it will be here, he's going to fall in this one, and the counter is going to say counter plus plus. So when we are going to be here, the counter is going to move to 1 because it has been reinitialized here after this one being computed. So by doing so, you are 100% sure that you're not going to mix counting the subarray. And then when it is greater, why am I doing this when it is greater? Because when it is greater, we are starting everything back. When it's greater, so we're not going to see someone like this, we want to reinitialize our maximum because this is the new maximum. We want to make sure that our solution is actually considered as 1 because it's actually our solution, the first one, and we are initializing our counter again at 1. And the one thing interesting, at this point you can run this. I think it will work. If you run this, it will work. Yes, it's working. But there's one edge case which is really important to take in consideration. Let's say I have something like this. Let's say I have 4 4 4. This one will fail. Yes. Why is it failing? Because after, when my maximum is at the end, there is no way I'm computing my maximum when it's at the end. There is no way for me to do it because I'm doing this when I'm seeing an element breaking the continuity. And if my maximum is at the end, there will be nothing breaking the continuity. So I need to do again solution. Maybe just copy the same line and place it here to make sure that if there's nothing breaking the continuity at the end, I'm still able to compute the length of the continuity. If I run this, now it's working. Let us submit. Yeah, it's working perfect. So this was my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new video. Ciao.